randomized design. The term itself almost defines itself, I think. Completely random design, randomized design is when experimental units are assigned to treatments completely by chance. We assign them completely by chance. So, a question that's been asked by every class so far is problem number 69 on page 265, and it talks about these treating prostate disease. When we do randomized design or any kind of design, we can sort of make a roadmap for that design. So here's what that roadmap might look like for our situation that was asked earlier. We have 300 patients. And we take those 300 patients and we randomly assign them. There's lots of ways to do that. We do some sort of random assignment to 2 treatments. In one case, we have surgery. And we want to randomly assign 150 to surgery. How you choose to randomly assign, there's lots of ways. Again, lots of ways to do that. The other thing is non-surgical. And we'd also assign 150 to that randomly. Names in a hat. Number of people 1 through 50 or 1 through 150. Choose 75 randomly. Nope. 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 Alphabetical is not random. It doesn't seem like it wouldn't be, but it is not. So, yeah.
Wouldn't that be non-ethical?
What's that, too?
To use people for non-surgery and surgery for lasting effects after surgery?
Well, but in this particular problem, it said that after the survey was originally done, they found that it was false. That, in fact, they believed there not to be a difference between the two. So if you believe there to be no difference in this, then no, it wouldn't be unethical.
Okay.
But if you'd already shown that surgery was more successful, then yeah, there would be an ethics issue.
Okay.
Yeah, I agree with that. Yeah. Yeah, these 300 patients are volunteers. Yeah, so they know that they run the risk of getting the better or the worse treatment too. And then we come back after some time, after some recovery and all that, and we compare results. Okay, and this is how a completely randomized design would look in terms of like mapping it out. Now, you might have more than one treatment. You could have 5 different treatments or whatever. This could certainly expand a little bit. This is a basic one. All right, we good with completely randomized? Let's talk about randomized block design. Randomized block design In this case, experimental units are put into blocks based on some known similarity. You can think of blocks as being groups based on some known similarity. How might things be blocked? What kinds of things are similar? Could be gender, age, could be race, yeah. Especially in terms of medical treatments, different races do respond, I understand, differently to different medicines, or at least to different diseases. You could be blocked by body type. How healthy are you? How physically fit are you? There's all sorts of things. You could be blocked. Well, you wouldn't be because you're not cars, but you might be blocking cars by sedan versus SUV versus truck or something like that. There's lots of ways to block things. Lots of reasons to put things in a same kind of context. After they're blocked by this some known similarity, then random assignments are given to each block. Random assignments are given to each block. So let's take the same scenario of our colon disease people. Wait a minute. Prostate. Is it prostate disease in the problem? I thought it was a colon thing. Oh well. So then it would all be men, wouldn't it? Okay. So in this case, we have 300 patients again. I gotta kind of squeeze it over there a little bit because this one's a little bit longer. And the first thing I do is I separate these guys in by, let's say, healthy versus less healthy. Okay, let's say we're blocking based on some health factor. I could. Once we do that, well, okay, backing up a little bit, are these groups necessarily equal? Not necessarily equal, right? That's okay. We've blocked them the way we think that we need to. Then we would do some sort of random assignment in both cases. And that random assignment would send them either to surgery, bless you, or no surgery. And surgery, no surgery. Then we would bring this information back and we'd compare the healthy and the non-healthy. And at the very end we would compare the results. researcher, there's probably a good chance that some of these not so healthy people may not survive surgery. I have no morals and I'm heartless, so I don't care. Okay? But can you see a potential moral dilemma here with that? There certainly could be. Yeah. Putting some.
Ethical dilemma.
It is an ethical dilemma.
No, it's definitely a moral dilemma. It is an ethical dilemma.
What-
There's a difference between ethics and morals.
Hey, this guy signed up for this.
Yeah.
This is the way the dice rolled, so this is his luck. So, if you ever walk into a research facility and you see me, you should probably walk out, because I'm going to be like, oh yeah, that one asked all those questions. I'm gonna make sure they get put into this block or whatever. No, I'm kidding. I wouldn't do that. All right, but I could think about it. You guys are a tough group. All right, one more. Matched pairs design. This one can be a little tricky. See, my goal is to prepare you guys for the real world. I don't want you guys walking out of high school thinking that all teachers are like, goody goodies, and we all care about your health and all that. Are you kidding me? I'm here for the paycheck. No, I'm kidding. I'm kidding. If I was here for the paycheck, I wouldn't be here. All right. Twins. Okay, matched pairs design. I want you to think twins. It's not always twins, but it's twin-like situations. Okay? But identical twins are they're perfect research candidates for so many things because they have identical DNA, or I guess nearly so, I don't know, right? So identical twins, but a matched pairs design is really like a block of two. Where two experimental units that are very similar or the same are randomly assigned a treatment each. There's only two treatments involved. Where two experimental units that are very similar or the same are randomly assigned a treatment each. Again, identical twins are perfect for this kind of situation. In fact, I had a couple of years ago, at one point or another, I think throughout the year, their 4 years, I had both of them, I think. But when I talked about this, and one of them was in my stats class, they said, oh yeah, we've been approached for that. So they said they'd never done it, but they'd been approached for it. But it doesn't have to be twins. It could be two people that are similar in some ways. Maybe both female, both active, both of a similar age. That's how you could kind of block in pairs, do a matched pairs design. Another example would be a car or two cars. Take two cars, maybe they're the same model, the same year, and they have the same options, and you're going to compare them. Maybe one of them you put a special type of oil in and the other one you don't, and you run it for however many miles and you see what the engine wear is. So that would also be a matched pairs design where the cars are twins. There's another way that this happens, and it happens more often than not probably this way. The experimental unit receives both treatments. The experimental unit receives both treatments. Doctors do this all the time, or at least I think they should be. Hey doc, I think something's wrong with me. Oh, you've got high blood pressure. Great, I have a perfect pill for you, I think. So they prescribe a medication, take it for a little while, you come back to the doctor and they say, how's it going? Well, my blood pressure seems to be good when I check it, but I've got these other problems now. There are side effects oftentimes to medicine, right? So here are my side effects. Okay, the doctor says, all right, well, let's take you off that one and try another one. Usually there's some period of removal of the one, you know, you take a couple days off or something like that and you try another drug. That's a matched pairs design. You are the experimental unit. And the doctor is giving you two treatments at different times, of course. Another example would be, getting back to cars, because I do car stuff quite a lot. There's a couple different types of fuel that you can buy for cars. You can buy the stuff at Chevron and Maverick and all that. It's got ethanol in it, usually somewhere around 10%. Or you can buy non-ethanol fuel. It's a little bit more expensive, but it gives you a little bit more power and supposedly better fuel economy. So I've done this a few times where I've taken a car and I've filled it up with the ethanol fuel and I've driven that tank out and I've seen what my gas mileage was and how much it cost me. And then I compare that to the next tank being a non-ethanol fuel. And yeah, I got better gas mileage. But I've never found that in that experiment on my own, I've done it with a couple different cars, I've never found the non-ethanol fuel to pay for itself, meaning that the extra added cost is more than what the added mileage was able to give me. Now, have I done it 100 times? No, but to me, but that it wasn't worth the money. But that is a matched pairs design. Same car, two different fuels. What's the mileage? Okay. Got it? All right. I want to say that there was a problem that I wanted to go over with you guys, and I'm trying to think of which one it was. What did I do first period? It was 71. Yeah. Let's look at number 71 real quick together. A fruitful experiment. I can relate to this one. It's sort of where I grew up. A fruitful experiment. A citrus farmer wants to know which of the fertilizers, A, B, and C, is most effective for increasing the number of oranges on his trees. He is willing to use 30 mature trees of various sizes from his orchard in an experiment with a randomized block design. Describe a randomized block design for this experiment and justify your choice of blocks. Okay, let me draw this out for you and see what you think. So let's say this farmer has their 30 trees. So my X's will be my 30 orange trees. Now, how should we block these trees? before you try to answer that question, let me throw a scenario out at you. Let's say over here on the edge of this orchard is wheat. We have-
You're off by 5.
Missing trees.
Am I? Okay, well, let me get, oh yeah, I am off by 5.
Missing orange juice gallons now.
God, yeah, man, not very productive, am I? Okay, there's a wheat field, and over here there's a irrigation ditch that runs along here. And we don't know what's over here or over here, perhaps. Maybe more trees, who knows?
We could put a tree there.
Would the irrigation ditch perhaps cause some issues with this and how we should block it? Okay, how about the wheat field? And anything else around it? We don't really know, right? So how we block this should probably be pretty creative. It doesn't really make sense in my mind to do a completely randomized design where you take 10 trees randomly and choose them. Because if you do that, it might be very difficult to remember what trees you put that fertilizer on, and there could be enough mixing of the fertilizers that it's an issue. Okay? So how might you choose that? Yeah.
Go by like the rows of 5s. Like take 2 of the rows, and then 2 of the other rows, and 2 of the other rows, 5.
Okay. I think I agree with that.
You do every other tree.
Well, I think if you do every other tree, I think what's going to happen is you might have some fertilizer mixing between the trees, and then it might become hard to know. You know what I'm saying? So the roots on this tree might reach over here where it catches some of the other fertilizer. Does that make sense? So I think you probably, have you guys ever seen an orange grove?
Yes.
You know? Yes?
I lived in Florida.
Cool. Florida has crappy oranges. That's why it's all juice. California has the good oranges. It's true. It's true. Okay? Florida orange juice, it's because they're crap. When they set up orange rows, the orange trees in the row are pretty tightly packed, and they look like big bushes. They go all the way to the ground. Okay? And then they leave some space between for the tractors to come through. So there would be some space here, but not necessarily here. Okay? So we've got space here, but probably not this way. So if we did rows, how could we randomize that somehow? If we did horizontal rows, we'd have to add some randomization to that. Eeny, meeny, miny, mo. Not random, sorry. Die, random. Numbers in a hat, random. Eeny, meeny, miny, mo. Sorry. How could we do it? There you go. So what if I assigned this as row 1, row 2, row 3, row 4, row 5, and row 6? And maybe I flip a coin. That's a random number generator. I mean roll a die. I roll a die. And let's say the die comes up with 2. What's the problem if I get, well, it's random. Let's say I get 2 and 3 for one set. And then I get maybe 6 and 1 for another set. Does anybody see some potential problems with that? Here's one group, here's another, and then this would be the third. There could be some issues on the edge of on the edges, right? That could be, maybe it gets less water. Maybe there's a road there that kind of draws the water away. So it's a tricky problem. What the best answer here is, in my opinion, would be hopefully this farmer has more than 30 trees and he can pull 30 trees out of the center of his grove somehow. Yeah.
That's true. I feel like if you go like every other one, and just put a different one, it's like row 2, row 3, row 4.
So like
That way-
treatment A and treatment A
Yeah.
and treatment B. Uh-oh. Uh-oh.
How many treatments are there?
It's 3. So maybe you go A, B,
So
C.
A, B, C.
Yeah, the problem is that's not random.
Okay.
That's the problem. You have to incorporate some element of randomness for it to be a good design, okay? Now, in the real world, maybe this is how the farmer does do it. I don't know. But for the stats world, this really wouldn't be a good way to do it. At the same time, I can see the benefits to it.
Yeah, because then you have one on the edge and one on the
But the A's and the C's have the edges, right? Everybody gets the irrigation ditch, but yeah, it's a tricky problem. Okay, so moving on. Explain why a randomized block design might be preferable to a completely randomized design for this experiment. Okay, to me, B is simple. If you do a completely randomized block design, it's going to be hard to keep track of which trees got what treatment. So for B, I'm saying, it's an organizational issue, I think.
Mr. Henry,
Yes.
why are California oranges red compared to the other colors?
No.
No, it's the other way around.
Yes, why are
It's the other way around. I don't know. It just probably has to do with the climate and maybe the soil. But all the oranges that you eat in the store are pretty much all California oranges. And all the oranges that you drink in the orange juice are Florida oranges. Not all of them, but mostly. Texas is growing citrus now too.
It smells so good though.
What?
Like when orange blossoms are around, it smells so good.
Yeah, I think it's just an organization problem here with this, frankly.